I put the name up, you must decide on something very obvious. But I'm going to not say it because you will know what this is about. And I'll put the name up. The name is Hideki Yukawa, a Japanese. In 1935, 2 years after Enrico Fermi of 1933, he was the one who wrote about what is happening or potentially could happen in the nucleus and what's going on that's holding the nucleus together. What's holding these protons and neutrons together? So he was the one who established, who wrote down, who laid down the founding principles on the knowledge of the strong force. Yes? We'll move on. When we talked about gravity and Einstein, sometimes what's not recognized is that Einstein, in 1905, established the quanta of light, meaning that he brought forth the knowledge to the world that light is not just a stream, just a beam, that actually light is broken up into quanta, broken up into packets, broken up into bundles called photons, discrete packets. This was brought forth by the great Albert Einstein. But interestingly, he knew this Indian was reading his works, like all of the scientists of his day, because Einstein established part A, his first astronomy, cosmological, particle physics toolkit. That was first established in 1905 with special relativity, and obviously became magnified and even greater when he released the general theory of relativity in 1915. But in 1905, and in that time period, he had a contactee. This person was Satyendra Bose. And interestingly, he was the one who described the photon more accurately than everybody in his day and time, including Einstein. So profoundly that he actually flew over from India and met Einstein, and they became friends. You can see pictures of them on the internet with no problem. So this Indian physicist was so great in his day. Like other great physicists, he also contributed to our knowledge of the cosmos. And in this case, the knowledge of light frequencies, like when we say visible light, that enables us to see by the visible light from the sun hitting the optics of our eye. Okay? Now, what we must also talk about is, of course, Einstein himself. Because in upgrading the knowledge of gravity from Newton's old information, because knowledge should increase, and he increased it. So he would think deeply about the universe and about how things move and what makes up the universe or cosmos. And in his thinking process, he came out with an astounding revelation. And that, in actuality, gravity is a mix of mass or matter and its impact on space itself, which is not empty but is a fabric. And to put it in perspective, it's like you have a bouncy castle, and in the bouncy castle, a child bounces on the castle. This will be symbolic or synonymous with the castle being space and the person being an object, or the sun displacing its weight in the fabric of space, or planets displacing its weight in the fabrics of space, but being influenced by a heavier mass or a heavier weight by the sun that causes the motion. So what has been established by Einstein was that because the object or mass in the fabric of space causes space to bend and curve, this causes motion. So mass impacting space causes motion, and that is your gravity. Not a pull, but because of the effect of mass or weight on the curvature of space. So, there you have it. Those were the BRAINS that helped us to know about the cosmos, the universe, and how it's made up and how it came to fruition today. But the class is titled The Brane versus the Big Bang. And the spelling is not BRAIN, but BRANE. What is a brain? Well, what you have here, you have two sheets, so to speak, right? Which in cosmological terms or theoretical physics terms would be two brains. What is a brain? Not two sheets of paper, but in theory, the brains are geometric entities. They are geometric objects. And interestingly,